Hello everyone, welcome to i-Vidyapeeth, Padai V and Progress V. I am Arindam. I discuss about cloud AWS, generative AI and blockchain technology. In this particular lecture, we will discuss about the generative AI basics. So in recent years, we are seeing there is very hype around the AI, specifically the generative AI, right? There are a lot of terms we are hearing like chat GPT, DeepSeek, MCP server, fine tuning of the model, but these are the very high level terms. But what are the internals about it? So this particular series is about that. So let us start with the basics and then we will gradually go to the higher level. So I will cover from the scratch up to the advanced level. So kindly follow i-Vidyapeeth, and there are also several courses available around cloud, AI and blockchain at i-Vidyapeeth Academy. So in this particular lecture, what we will discuss about what is generative AI, like the basics of generative AI. We will discuss about the expert systems, how the foundation models are created, how actually it works, what are different model learning techniques like self-supervised learning, reinforcement learning, etc. Then we will discuss about the usage of foundation model, that how you use this particular foundation model to create actually enterprise level use case. We will discuss about the context window and the input context window, output context window, and what is the token limits and etc. apart. Then we will discuss about the very basic high level of RAG approach and the fine tuning part. So this particular lecture is for beginners, and let us concentrate. So first of all, let us play a game. There is a dotted line present over here in this particular slide that clouds are. So what is coming in your mind? Clouds are. There can be multiple different options coming, right? So suppose I am telling the clouds are gray and you are telling clouds are white, right? So there are different options are coming up and we are telling some particular option, okay? That clouds are white. You are giving a particular option. So just try to understand that how you are giving this particular answer, right? So how you are giving this particular answer, because you have learned this particular English language, you know the grammar, you are understanding that clouds are, this is the English word, right? First of all, then you know that what is the meaning of cloud, what is the meaning of are, this particular verb. Then via your learning and your experience, you are telling that particular word. There may be multiple words coming in your mind, but among them you are choosing one particular word and telling me, right? Clouds are white. So you are generating some word, you are filling the next word, and then completing this particular sentence. This is the generation. So we need to concentrate on the generation part, the generative part. This is very important. So the way you are actually generating this particular word, we are trying to mimic the same thing inside one machine. So that if we are telling clouds are and we are giving this fill in the blanks, they are able to answer. So we are trying to train the model in such a way so that they can generate this particular word and tell us, right? So this is one of the very basic example. If you think like this, then the idea will be very clear that how you are generating. You are generating based on your learning, based on your experience, and the learning is multimodal. You have learned via picture, you have learned via different websites, you have learned via your textbooks, you have learned via your audio. So you have learned in a different way. That is why you are able to come up with this particular answer, right? So you are generating this particular answer. That is the thing we need to understand for the generative AI. So we are trying to implement some kind of intelligence artificially inside one machine so that it can predict the next word. This is the generation. Okay, let us move to the next slide. So this particular slide will give you the idea that what is the main crux of generative AI, that what we are trying to achieve from generative AI. Generation can be multiple things. Like you can generate multiple things. For example, if I tell just please write one poem, imaginary poem, right? Anything. And you can write any imaginary poem for me. This is the creativity part of you. If I am asking some question to you, right, that what is the capital of India? you are giving me the answer. So this is coming from your knowledge base. Like you have read that particular word, that New Delhi, and you are then giving me the answer, right? So something is coming from your creativity, something is coming from your knowledge base. Based on that, you are giving the answer. So you are generating something. Whenever I am telling something, you are generating something. Whether that generation is coming from your knowledge base or whether this generation is coming from your creativity part, I don't care. But you are generating something. Exactly the same thing is happening inside generative AI. If I am telling that please write one poem, I am telling one model, for example, ChatGPT. ChatGPT is very popular, right? This is the product from where this generative AI actually taken this hype. So if I am telling that ChatGPT, please write one poem on bird, then it can write for me. If I am telling that create some digital art, that one bird is there in the green tree and etc., it can generate this digital art. It can also compose the music for you, and most importantly, you can generate the code. If you write that, okay, please generate one code, addition of two numbers in Python, it can definitely generate it for you. So there are different capabilities available inside the generative AI system. So generative AI is actually multimodal. It can generate the image for you, it can generate the audio for you, it can generate the text for you. So different things are possible via the generative AI. ChatGPT is primarily the large language model where we are generally doing the interaction via text. Now ChatGPT is coming up with different features, different multimodal features that we will discuss in other lecture, but this is the basics class. So just try to understand generation can be multimodal. It can be via picture, it can be via audio, it can be via text, right? So I think this slide is clear. Let us move to next slide. Now let us look into the expert system, right? We are talking about generative AI, but generative AI basically belongs to which category? That we need to understand. So first of all, the artificial intelligence is not new. It is prevailing from very beginning. Like I think it is from 1960s, 70. From that time, this artificial intelligence term came up, right? After that, whenever first time this artificial intelligence this term came up, there was the rule-based system. Just try to understand. Let us give me one example on a cat, right? So if I am giving you one picture, showing you one picture, right, for cat, and telling you that please identify which animal is this. You are telling cat. How you are telling? You are telling from your experience, from your learning, because you know that how the cat looks like. But initially, from the initial days, there was not such kind of machine learning system available. Everything was rule-based system. That kind of rule-based system was called the expert system. So now try to understand, to get the understanding that this is the object, right? This object is the cat, or this animal is the cat. How you will identify? There are a lot of rules are available, right? There are a lot of rules available. How many rules you can write? If else, different loops you will write. Okay, if this particular feature is available, then this is cat. If this particular feature is available, then this is cat. This is not possible, and this is very much inefficient. So machine learning came. So in machine learning, what we are telling, we are specifying some feature. For example, the nose type, the eye type, the fur pattern of this particular cat. We are telling that please try to learn these particular features of this animal. We are telling these are the features of cat, and try to learn it. We are giving lots of examples. There are lots of examples we are giving. We are giving 1,000, 2,000, 10,000, 20,000, 1 lakh of examples to this machine learning system. We are training them. But what we are training, we are giving them the particular object. We are telling them that yes, this is the cat, and these are the particular features which are available. Try to learn from it. Okay. So this is the era of machine learning. Machine learning is one of the subset of artificial intelligence. Artificial intelligence is a superset. Machine learning is a subset of it. Okay. But there is one problem, because the human who is actually training that particular model, they are actually telling that please identify these particular features of this object. It can be possible that we have missed few feature. Okay. So we suppose, for example, we are telling that please identify from the eye and the nose pattern, barking type, and the fur pattern. Okay. But if you are showing that cat from one angle, suppose you have taken the picture of the cat from the back side, from some angle, then if you are telling the machine learning model that yes, this animal is cat or not, then it will not able to answer, because it will be not able to identify those features. The eye is not visible, nose type is not visible, that cat is not barking, right? Right? It is not telling meow. So definitely this machine learning model is not able to understand it. So there are some limitations. After that, the deep learning came. Deep learning means we are telling that this is the particular object, cat. Now try to identify the features on your own. We are not telling about the features directly. So the deep learning model, this neural network specifically, this neural network, I am not going into that details because this is the first lecture. I am not going into what is neural network and etc. But just try to understand that we are giving some example and telling them this is the example of cat. There are lots of example, and try to identify the features on your own and try to train that particular system. So this is the example of the deep learning model, right? After that, what happened, so deep learning, again, we have to specify this particular object, that this is the cat type. After that, generative AI comes. So in the generative AI, what we are telling that no, we are giving you large amount of data, large set of data. We are not telling that this particular data set is about the cat or this particular data set is about the dog. We are not telling them. We are just giving you large set of data, and we are telling that please identify the features, please identify the object on your own. That is the self-supervised learning. If your teacher give you something, the book, just please try to identify that what are the key points in this particular chapter and what is this chapter about, you will be able to understand because you already know the mathematics. For example, you are learning one new chapter of mathematics. You will be easily able to understand that yes, this is the mathematics chapter and these are the important points because this is highlighted in bold letter. And these are the previous year's questions. So this will be important question. I need to solve the PYQs, right? So this is the self-supervised learning. So self-supervised learning where this generative AI come. And after that, this self-supervised learning, what is being created? The foundation models are created. The foundation models are like the GPT-4, the Llama, Mistral, DeepSeek. These all are the foundation models. That means that they are the base models. So these base models are created, and then that base models are trained on different data to create some kind of specific model. That is called the fine tuning of the model. We will come to that. But now just let me summarize this particular slide, that artificial intelligence is actually the superset and machine learning is the subset of that, and deep learning is again the subset of this machine learning, where we are just specifying that particular object, but we are not telling about that features. It is learning on their own, but we are specifying that particular object. That is, this is the cat feature. But in generative AI, we are not specifying anything. It is self-supervised. We are just dumping the data and telling them, please identify the features, please identify the subjects and learn on your own. And there are huge, large amount of data. That is why it is called large language model. And basically, these are the foundation models. So large language model mostly deals with the textual information, and there are other category of models like vision language model, audio language model. Different models are available. So these are in very high level. We will go into deep. In this series, we will go into deep, but just try to understand the basics first. Then the mind map will be clear to you. Now, let us understand the how we create a model. I told that we are dumping a large amount of data, right? And this particular model is getting trained on its own. But how it is getting trained? Very interesting, because whenever we are inserting some information, inserting some textual information inside the model, some machine learning model or the deep learning model, right? So basically, it should be computer acceptable, right? We know that whenever we are compiling any C program, C++ program, it is going to the assembly level, and then it is finally converting into the binary format. In the same way, whenever we are first time collecting the data collection is very important, because the knowledge is very important. The more data set you are training, and the more like fine-tuned data or pre-processed data you are giving and training the model, the model will be performing more good way. Okay, so first of all, the data collection part is very important. After that, the pre-processing of data. Okay, so we are removing the duplicate information, and we are just creating some kind of formatting the data so that the model can understand, and then we are creating the tokens out of it. We will go into the details of the tokens, that what are tokens, how the tokenization work, what are the different types of tokenizations things are available, that we will discuss. But just try to understand that we are just trying to prepare something which can be readable by the machine, right? So pre-processing and tokenization are done. Then we are giving this input token to the neural network. Okay, and then telling this particular neural network that please predict the next word. Please predict the next word, because we are training them, and we are training them via the self-supervised learning method. So whenever we are telling that please predict this next token, then this model is actually predicting that next token, means the next word, for example. So if I am telling clouds are, if someone is telling the clouds are violet, this is not the correct word, right? Clouds are white. So if that particular large language model is getting trained and it is telling that clouds are violet, then definitely the model needs some kind of improvement. This model has given the wrong answer. It needs to have some kind of improvement, just like normal student. Whenever you are answering something and you have done something wrong, you are going to that particular chapter and revising it, right? Then again you are giving the mock test and the exam. This is the way how we have prepared till now. The same analogy is being applied whenever we are creating the model, that we are giving some text, we are masking some information and telling that model to generate the next word. If the next word is matching with the expectation, means the actual training data, then it is good. Okay, the model training is correct. But if it is not, then the model is self-rectifying itself. It is adjusting. How it is adjusting? It is adjusting via the loss calculation and the back propagation technology. That is adjusting the weights internally. So basically in the neural network, there are different neurons are available, like in our brain. Okay, and they are connected via different layers. We will go into that. We will learn about the neural networks, that what is the neural network, what are different things, but just try to understand there are different layers, and in each layer there are different dot and the connected points are available, and these points are connected among each other via some weight. Okay, so A to B is 0.5, B to C is 0.7, something like that. So there is one layer and different neurons are available. So these weights means the relationship between two neurons are getting updated. Even the relationship between two layers are also getting updated over here. In this way, they are learning it. They are learning it via the back propagation and the loss calculation. And whenever they are thinking that, okay, the training is completed, there is no problem, the model is able to predict the next word correctly with a good probability score, then we are telling that the training is completed. Okay. So this iteration is actually being done for billion times. That is why we need large GPU machines, right? That is why it is very much a costly affair. If you want to train the model from scratch, it is very costly affair. That is why we are generally taking the base model. We are generally downloading the base model from Hugging Face or GitHub and then train on top of that. Because if you want to create a model from scratch, it actually requires a lot of computation power. So a lot of costs are associated with it. So just to summarize this particular part, that how we create the model, first of all, the data collection, the large amount of data, the clean data, the very good data set you need to collect, and versatile amount of data, definitely, because you are trying to create the general purpose model, for example, like Llama 2, like Llama 3.1. So you want to create some general purpose model. So you need to have versatile amount of data. Then you pre-process the data format or do something according to your internal architecture based on which you are going to train it. Then you are making it machine ready via the tokenization. Then you are inputting this thing inside the neural network. So that neural networks are connected via different neurons, and that neurons are connected via different weights, and that weights are getting updated. That weights are actually the learning. So whenever we are learning something, right, in our brain, the neurons are getting that information. We are storing that information. You can understand. So in the same way, we are like storing some information inside the neural network via the term called weights. And this weight is getting updated and via the self-supervised learning. If it cannot predict the next word, then at that particular time, it is calculating the loss and doing the back propagation, then updating the weight again. Means you are rectifying yourself so that you can memorize. Like the same analogy what I have given for the exam, right? You are rectifying yourself so that in the next exam, you can give the correct answer. And the final thing, the save checkpoints, because whenever we are training the model, we can save that particular checkpoint. It is the same thing like the versioning method, right? We will see the details, but this is the basic thing. Just try to mimic this thing with a human training method. The generative AI training method is the same like how we are actually training ourselves. Okay, that's the same way it is also getting trained. So in our next lecture, we will discuss about the embeddings, tokenization, weights, what are the nuances of it, we will see about it. But right now, just understand this part. Now let us go to the next slide. There are different learning methods are available. So we already talked about the last one. There is a self-supervised learning. Okay. In the self-supervised learning, what is happening? This is a label data set and predict the next missing word, minimize the loss. Okay, so we have given the labeled data set. Why the labeled data set? You know, because we have given the whole information, right? The clouds are white. The color of the cloud is white. So we have given the labeled information to them, and it is doing the self-supervised way. It is masking that part and then again trying to predict that particular word, and based on that it is adjusting the weight. So this is the self-supervised learning. We are giving the labeled data set. Okay. Now let us look into these two different categories. That is a supervised learning method and unsupervised learning method. So in the supervised learning method, suppose for example, this is the machine learning model. Like I've given the example of cat. Like we are giving the subject that this is the data set of cat and these are the features you need to train on. So known label data set that includes the desired input and output. So we are providing the input, output and the known label data set. So it is getting trained under your supervision because you have given the label data set to it and you have also given the input and the output and the subject also, right? So there is a thin difference between the supervised learning and self-supervised learning, because self-supervised learning is also the supervised learning, right? But it is self-supervised learning. We are providing it, but we are not telling that which features you need to understand. It is actually creating the features on their own, and based on that it is getting trained. But in case of supervised learning, like normal supervised learning, we are telling that this is the subject cat and these are the features you need to look into in the data set, and based on that you need to train yourself. The next portion is the unsupervised learning. Unsupervised learning, for example, like we are giving a large amount of data set and telling them for the categorization. For example, the financial data set. Okay, so in the financial data set, we are not telling that, okay, just based on this particular feature, you have to train yourself. They just try to understand that what are the outlier. For example, like you are doing some financial transaction, right? And someday, like you have done the transaction of 10 lakh rupees, but generally your transaction is not like that. So it considers this particular transaction will fall into a different bucket that needs to be investigated. So this is a kind of unsupervised learning example. And another example is the semi-supervised learning. So semi-supervised learning is kind of thing that first of all, we are giving the label data set, for example, some kind of medical records, some kind of information, some medical record related information we are giving. And then some set of information are the supervised one. Then we are telling that based on your learning, we are giving you data set. Now just try to match on it. Means whatever you have learned, based on that only you have to create your learning set for the next one. So semi-supervised learning is a mixed of, is a combination of labeled and the unlabeled data. So we just like in unsupervised learning, that we are not giving the labeled information, right? We are not giving the labeled information. We are just giving some dump of information and it creates two, three different segments. It is creating or telling the transactions in different buckets, the suspicious transaction, normal transaction. So it is creating by the pattern itself. So we have not given any label that this should be suspicious, this should be, no, we have not told them. We have just dumped them. This is unsupervised learning. But in case of semi-supervised learning, first of all, we have given the labeled data set. Based on that, train yourself. Then we are giving unlabeled data set. So based on your training on the labeled data set, now train yourself with this unlabeled data set. So whatever you have learned till now, based on that, learn yourself. Just like the medical records, because we don't have that amount of information, X-ray information or something like that, right? We don't have all those information like ECG, X-ray. So we are giving some information to it. Then we are giving some unlabeled data set. We are not telling that yes, this ECG is good, this ECG is bad, or something like that. We are not providing it, right? Now, next coming the reinforcement learning. So reinforcement learning comes after the pre-training of the model, when the model is already trained and the foundation model is created. After that, what is happening that, for example, like we want to fine tune the model. So fine tuning part is basically the reinforcement learning comes into. So whenever we try to mimic this particular model, for example, we want to mold this particular model to train the data set based on our domain, based on the banking domain, based on the healthcare domain, we want to train the model, right? That is the part of the reinforcement learning. So it is the same thing. You can understand what I told, like the loss calculation and the back propagation. So here, for example, I am fine tuning one model on the chess playing, right? Such as playing. So if that particular model, so whenever I am training that particular model to play the chess better, right? So if that particular model is doing the wrong move, then it is actually getting some penalty. Okay. AI will avoid that thing in future because this is a bad action. So I am giving the penalty to them. There are some penalty mechanism. I am not going into the details, but if that particular model is not doing the correct move, then it actually learns that I need to avoid that particular thing in future. In that way, it is learning that what to avoid. What to avoid. Because whenever you are failing, you are trying and failing something, that means you already learned that how not to try this particular methods, because that method already failed. So there are some other way to achieve the same. So this is the reinforcement learning. Means if you are doing the wrong thing, the model is doing the wrong thing during the training, which should not be, that means it learns that I should not do like that. And if it is performing the correct action, the correct chess playing option, for example, I am just giving one example that I want to train the model based on the chess. I want to train that particular model, that model should actually play the chess correctly. So if the good action is performing the good action, then AI learns to repeat them. If they are performing the bad action, then AI also learns how to avoid them. So gradual improvement over time will come. So it's the same thing like a student, right? Whenever we are teaching the student is learning something. Whenever it is actually solving one problem, then it knows, yes, this particular problem is getting solved in this way. That are the good action. And the bad actions are, whenever they are doing the mistake, they know that, okay, I will not do like that. I have done some mistake, right? So this is the reinforcement learning. Let us go to the next slide. So we talked about foundation model, right? How the foundation model is created. Now, how we can use this foundation model. This is very important. Like, this is our part, that whenever we are using this chat GPT, right? We are basically doing the prompt engineering. Chat GPT is not easy. Means if you prompt something inside chat GPT, it will give you some answer, but you are not utilizing the full potential of chat GPT. That is why you need to understand what is prompt engineering, how this particular model works, and what are the different ways you can prompt engineer any kind of model like that. Okay, so the first thing, how we can use the foundation model is via the prompt engineering technique. Next one is RAG, that is the Retrieve-Augmented generation, that we will discuss about. One dedicated slide is there. So in this way, so I'm just giving you the overview that foundation models are trained on like some basic information, like the public information. But if you want to use the model on your private information, private company documents. For example, you are a bank, you are one telecom industry, or any kind of business where you don't want to share your information to public, then you have to use the retrieve augment generation method, that is the RAG method of the large language model. The last part is the fine tuning. Fine tuning is basically where you want to have some kind of model in your domain, means there are large set of information. There are large set of information and you want to train one foundation model to train one particular domain, for example, right? Then you can fine tune the model based on that domain. For example, a banking domain, healthcare domain, you can fine tune the model with large amount of data of healthcare sector, large amount of data of the banking sector. So this is the fine tuning technique of the model that we will discuss, that what are different fine tuning techniques. Next part is the prompt engineering. So in the prompt engineering, we always know about this thing like zero shot, one shot, and few shot. So what is zero shot prompting, one shot prompting, and few shot prompting? That we need to understand. But that are the user prompt. Another prompt exists that is called the system prompt. System prompt means we are giving some kind of general, some kind of generic information to the model that please do this thing. For example, you are asking some question about technology, right? So you are telling that particular model in the system prompt that you are an expert. You are an expert in science and technology, or act as an expert as science and technology. Okay, and you are helpful assistant. You can do a lot of research or some kind of generic information you are giving. You are personalizing this particular model, or you are giving some specific information that whatever you have been queried, please don't try to make it up. Just answer within the context. For example, in RAG, right? Whenever we are sending the information to the model, we are sending the information, private information, plus the user query. We are sending it to the model. And we can tell the system prompt that please don't try to hallucinate. Please don't try to make it up. Whatever information is given you inside the prompt, based on that, give me the answer. Suppose I have given 2 pages of information and asking some specific question from it, right? Then I can give the system prompt to the model that please answer within the context, whatever in the user query or whatever in that particular information have been provided. So context is very important, right? In the context, the system prompt is also going. System prompt is the general prompt. Either you can personalize, like act as an expert, act your helpful assistant, act as an expert in science and technology, act as an expert in agricultural things, and this things, some generic information you are always giving. So user query will always be appended with the system prompt. Okay, because whenever you are creating some chatbot, you will always tell that please check whether the question is relevant to this particular company or not, then only you will answer. Or please check whether this question is relevant to this domain or not, then only answer, otherwise you cannot answer. For example, in Amazon.com, in the market, in the e-commerce website, you are going and you are asking that who got the or what is the capital of India. But that particular app, that AI assistant, is not actually created to answer that kind of query. It has been created to answer only the relevant query in the e-commerce website, right? Right. So in the system prompt, if you provide that only answer within the context, if the user is asking something whose intent is beyond the scope, like it is not asking about the e-commerce or something, then please tell him politely that this is out of my knowledge. Please ask something according to the e-commerce website. This is one of the example of system prompt where you are instructing the system. Okay. Now, context. So what is context? The context is same, that whenever we are telling something and we are giving some information to the machine, that is the context. That is the context. So system prompt plays one vital role inside the context because we are setting the context. That is why I have written the context word. So basically the context is more relevant in retrieval-augmented generation where we fetch the context from the private information. But here in the system prompt also plays one important role inside the context, because system prompt is where we can actually specify our answer format. We can specify the general information, and that will be appended with the user query every time. So whenever user will ask something, every time that query will be appended. So basically what is happening? This is the system prompt, right? One second. System prompt. System prompt is there. Plus, suppose you have given the user query, because system prompt is by default, it will be always present. Then the user query. Then the user query is there. Plus, optionally, the private information. These three things together make up this context. Okay. This private information we will discuss about in RAG. Okay. So these three things together is actually create your context. Okay. Now let us go to the user prompt. So in the user prompt, there are three kind of things. First of all, there is zero shot prompting. So let us understand zero shot prompting. Zero shot prompting is just blindly you are asking something, that please give me some or create some poem. Just you have given some blind. There is no such example you are giving. Just you are telling that please generate one poem on bird. That's it. You are not telling anything. But that is not correct, right? Because you may need in some formats, you may need to avoid some words, you may need it in some tone. For example, you need in some kind of creative tone or some relaxed tone or something like that. You need to specify it. You can tell directly, but you have not given any example. You are just asking it. Right? You are just asking that question as it is. Okay. No example. No example in zero shot prompt. No example. But in case of one shot prompting, we are giving one example. One example we are giving. For example, write one poem in 5 lines, and this is one of the example. You have given one example on different animal or something like that. So he knows that, okay, based on this particular tone, based on this particular answer type, I need to generate. And this is one of the example. You are mentioning that this is one example. You are mentioning, right? So this is one shot prompting. In few shot prompting, you are giving multiple example. Now, let me tell you one very good example for it. Okay. One of the example is, for example, I want to classify one sentence whether it is positive or negative. Okay. If I am telling that I am very sad, I am very sad, I am very sad. So whether it is positive sentiment or negative sentiment, right? I am just directly telling. I have not given any example. Then it is the capability at the learning of the LLM. Based on that, it will give me the answer. But in case of one-shot prompting, I am giving one example that, okay, please classify I am very sad. Then I have given one example that, okay, my mood is bad. This is negative sentiment. I have given one example that my mood is very bad right now. This is the negative sentiment. I have given one example. Then the LLM will, it will be very easy for the LLM to understand, okay, he is expecting the answer in positive and negative. And this is one of the example. Based on that, it can give you answer. In case of few shot prompting, I have given multiple things. Like, I am very happy. This is positive sentiment. My mood is bad. This is negative sentiment. Okay. I will not eat anything today. I am very angry. This is negative sentiment. So this kind of information, if we are giving multiple examples in the prompt along with my normal query information, that is called the few shot prompt, right? So in this particular slide, what we have discussed about the system prompt, which is the basic generic information which is present in your application. Means you want to avoid something, you want to apply something, that information you are giving, which will be always appended with the user query, right? This is the system level information you have appended the system prompt, right? Then we have discussed about the user prompt, zero shot, one shot, few shot. So example based, this is like the example, whether you are giving no example, one example or multiple example. Then we have discussed about the context a bit, that the system prompt information plus the user prompt plus some information which is fetching from the private repository, that is the RAG approach. These three things are called together the context. And this context is very important for the model because model has some limitation to have this context. It has some context window level limitation. There are some input context, there is output context, and there is a context window. So we will understand in the next slide that what is this context all about. Okay, so we always hear that this is a very large context window. Like recently the models are having large context window. For example, like Claude Sonnet 3.5, it is having the context length as 200K. Okay, the context length is 200K. So this 200K means this is the addition of the input token plus output token. Okay, so just try to understand that it is not like that the context length is high means you will be able to generate a lot of answer. You will be able to generate lot of output from there because the output tokens are limited. Though the context length is very high, it is actually for the input tokens. If I am telling the Claude Sonnet 3.5 2024-0620V1:0 for this particular model, the context length is 200K. That means the summation of input token plus output token is 200K, but the maximum output token it supports 4096. That means you have given a large set of documents and asked to summarize. It can summarize and give you the output in 4096. Maximum this amount of token it can give you. So what is token? We have not discussed token, right? So consider tokens at the word. Okay, like I think 3 tokens is 4 words or something like that. We will discuss in the next slide. I think 3 tokens 4 word or something like that. Okay, so just consider the tokens as word for now. Okay, so just try to understand that the long context window doesn't mean it will generate you long research paper, long thing. It is not like that. It means generally the input context window is large. Input context window is large, means input context length is very large for you, but the output is also is limited. That means you can give a large set of information in the input and can get the output depending on the model. Claude is supporting 4096 maximum token output, but Mistral Large is supporting 8192 tokens in the output, but the overall context length is 32K. So 32K minus 8192, that is the maximum support of the input length of this model. So this is very crucial to understand that the large context length doesn't mean it can generate large output. Large context length generally meaning it is the summation of input plus output, and we need to see the model card to see what is the maximum output token it supports, and rest of them are the input. So we can give a large set of input and then can get the output. Okay, so input tokens are the tokens from the user messages, that is the context, like the system message plus the user prompt plus your private information from RAG that you can give, and the output token are the model's response. Both input token and the output tokens are counted towards the context window limit. Okay. Next is the RAG approach. So what is the full form of RAG? Retrieve, augment, and generate. So till now, I was talking about the RAG thing. There's the context, right? So let me tell you one very basic scenario. For example, like you are having one business, right, and you don't want to disclose the information to public in the public internet because it has some kind of privacy policy. Every company, even every healthcare sector, everyone is having some privacy policy, but you want to actually uh, call the model, right? So that model will not have your information. If you ask your private information to the model directly, then definitely it will be not able to answer it. So what is the solution? The solution is the RAG approach, where you are querying something and then it is retrieving some information based on your query. For example, you are asking that what is the current revenue of this, the revenue of the financial year 2023-24, and you have not published it. These are the very basic, your internal information. Then what it will do, it will search some database or search some information from external thing. I will come to that integration, that where it can search. So retrieval doesn't mean that it can only search from a database or something like that. Retrieval means it can also search from APIs. It can also search from other third-party website, or it can also call your own servers or own documents. It can call your own block storage. It can call your own object storage like S3 and get the information from there. It can also do the query, SQL query in your database, normal relational information, relational database, or NoSQL database also it can query. So basically retrieval means there will be some system internally that based on your query, it will retrieve the information. Here in this particular thing, the agentic AI also comes in picture. The agentic AI also comes in picture in this particular part, that based on the user interaction, if that particular model feels that I need to extract this information, if the intent is like that, so based on the intent, whenever you are querying something and it is this framework, this internal framework will try to identify the intent, that okay, it try to have the financial information. That means I need to query the financial database. So first of all, it understands the intent, then it calls the financial database, get the information, then it wants to summarize the key points, then it goes to the LLM and then give you the answer. So this retrieval part in between, whenever the user queries, it wants to retrieve it. This retrieval can be from multiple places. It can be from the vector database. This is one of the term we will see in our next lecture, that what is vector database, why it is called vector, how it is related to embeddings, that we will understand it, right? So this retrieval part is very important, that whenever someone is querying you, there will be one system which will identify that where to query, how to query. I am abstracting that. That can be agentic system, that can be normal vector database based retrieval. But some framework we need to use. Either we need to use some LangChain framework where based on your user query, I am searching the semantically relevant information from the vector database, then joining those information and sending it to the LLM. Or we can actually get the intent based on some small LLM. We will talk to small LLM and try to identify the intent, and based on the intent I can query my own database, own relational or NoSQL database or DynamoDB, and based on that I can get that information, and then I can club those information and send it to LLM. For example, I want to summarize something, right? Summarize the financial, what happened, what are the key highlights of the financial year in my company 2023-24. Then it need to have those information, right? So key highlight of the financial information, it understand the intent, then based on that it fetches from multiple resources. It fetches something from API. Okay, this information is present in the CRM, so I need to fetch this information. I need to fetch this from the financial database. I need to fetch some semantically similar documents from my document store. So all those information are getting fetched based on one system. That system can be agentic, that system can be normal, sequential, right? But I am retrieving something. after the retrieval, user query plus the relevant retrieved information will be clubbed together, context will be created and sent to LLM. That, okay, summarize the key points. Then it will generate and give you back. We will have some dedicated section on this retrieval techniques. Okay, like how the vector database can be used, how we can use the relational database and etc. That will be, we will see in i-Vidyapeeth classes. The last one is the fine tuning, right? So fine tuning, I will not go into that much details, but as I told that fine tuning is basically like after the foundation model is created and you want to create your own version. Okay, you need to fine tune that particular model. For example, you want to fine tune the model on healthcare domain, you want to fine tune the model on the banking domain. So you need large set of information. So there are different ways how we can fine tune the model. Either we can fine tune the full model, that means all the weights will be updated, because initially I told, right, these are all the neural networks, the weights are getting updated. That weights are actually the final thing which you are downloading as the model. Whenever you are downloading the model and running the model locally, right, that is the weights actually. There are a lot of other folders also getting downloaded, but weight is one of the feature which you are downloading. So that weight will be updated based on your fine tuning, but that is very costly. So generally, we are following the parameter efficient fine tuning methods. So there is a low rank adaptation methods. There are different other methods are available. So basically what we are doing, the base model is same. We are just appending some layer on top of that. We are not disturbing the actual weight. So that is why the time is also very less, and also it is very cost effective. So there are LoRa techniques that we will discuss later in the i-Vidyapeeth classes. Okay, and there are some thing called instruction tuning, where you are just giving a large set of instruction set to the model to so that they can understand the user instruction correctly. So instruction based model, and reward it when it behaves well. That is the via the human feedback. Okay, so there are different ways how we can fine tune our model and make it on like how we want to have it. Okay, thank you everyone. Again, this is Arindam from i-Vidyapeeth. At i-Vidyapeeth, we have several courses on like cloud AWS, blockchain, generative AI, Docker, Kubernetes, and etc. And we will discuss multiple things over here also in YouTube, because I believe that जब पढ़ेगा इंडिया तभी तो बढ़ेगा इंडिया. Thank you from i-Vidyapeeth. पढ़ाई भी and progress भी.